It is not a rare sight to see people saying that they experience worse battery life on Linux than on Windows with the same hardware. Some people might have better battery life, but some will have drastically worse experiences. So I thought it would be nice to take a look at what you can actually do to improve that. If your laptop is a bit premature and finishes before you're actually done with it. So we'll see how you can squeeze out more juice from your laptop running Linux, but first we gotta talk about our sponsor, Tuxedo Computers. They make laptops and desktops and NUCs that ship with Linux out of the box. They let you pick from a selection of popular distros, but you can also just install your own, because in their testing, Tuxedo submit patches upstream to make sure that all the hardware is well supported. And if those patches haven't been accepted yet by the kernel or the Mesa drivers or any other system, they have repos that you can add to most major distros to actually fix these issues on your hardware as well. So when you go with Tuxedo, you know that the hardware is going to run under Linux, no questions asked. They have a broad range of devices, from laptops for office work all the way up to workstations or gaming PCs or whatever else you want. They are all pretty customizable with your own keyboard layout on your laptops, your own logo engraved on the lid, a solid selection of components, of hard drive sizes, of RAM, and all the laptops can be opened, repaired, and upgraded. So if you need a new computer, you want to run Linux, and you want to support a company that actually supports Linux, click the link in the description below and get yourself something from Tuxedo. Okay, so the first thing we're gonna take a look at when it comes to battery life is the actual health of your battery, because if it's 10 years old and actually dying, there's nothing much you're going to be able to do. So if you use KDE, you can check that battery health graphically. You just open the settings, then you click About this system and click on Energy. Here you will see all the stats for your battery, including its health. For my own laptop, it's 94%, solid enough, especially considering this thing is charging and discharging constantly. For a more desktop agnostic solution, you can run the following command line, present in the video description: upower-i/org/freedesktop/upower/devices/battery_BAT0. This command will tell you everything you need to know, especially in the capacity status. If your battery is already very degraded in terms of capacity, the obvious first thing to do is trying to replace it, because you are not going to get 10 hours of battery life on a 10-year-old battery. And I'm sure someone will tell me that their 2005 second-hand ThinkPad still has like battery life for days, but I'm also pretty sure that that's not the case for most people with such old hardware. Now, our next thing will be a pretty obvious one. If you watch videos or stream movies and shows from your browser, check that it is actually using your GPU to accelerate that video decoding, or even to render web pages. If not, then your computer is using the CPU, which sucks for this kind of tasks, and it will use more battery. To check that in Firefox, type About Support in the URL bar, then search for compositing in the page. If it says webrender, you're good, you're using the GPU. If it says webrender software, then it's the CPU, and that's no good. To check if the GPU is used to decode videos, you can also search for hardware_video_decoding. If it says default available, then you're good, you're using the GPU. On Chromium-based browsers, to check for that, you can type chrome://GPU in the URL bar, and you will see if video decode is hardware accelerated. And if not, you really need to enable hardware acceleration for rendering web pages and for decoding videos, because that's one of the biggest reasons that your computer might drain a lot more battery than what it's actually supposed to. The CPU is not meant for drawing stuff on screen. The GPU will be more efficient and use less battery life to do so. So on Firefox, to enable that, you can open the About config page. Then you can search for media.hardware-video-decoding.enabled. Double-click the value to set it to true. You might need some additional packages for that to work. If you use the NVIDIA proprietary drivers, you're good to go out of the box. It comes with everything you need. For Intel and AMD, you need to add VA API support if your distro doesn't ship that by default. This will depend on the distribution you use. You will have to check your distro's documentation for that. Most distributions should come with that out of the box. You shouldn't have anything to install, but if you use a very non-free software distro, like for example certain variants of Fedora or certain variants of Debian, you might not have them installed. Check on your distro's documentation. I just cannot give you all the instructions for all the distros in there. On any Chrome-based browser, you can just go to the settings, you can go to System, and toggle Use Graphics Acceleration when available. Provided your distro has the required packages, you should be good. Also, if your Chromium-based browser also completely changed how the settings look and feel, like for example with Brave, you might need to search through the settings for something called GPU or acceleration. And if you have an older chipset that isn't able to decode all modern video formats using the GPU, like for example VP8 or VP9, which are really frequently used on YouTube, you have browser extensions called Enhanced H.264 for Firefox or just H.264 for Chrome, which will let you set H.264 as the default codec on YouTube, meaning that you will always have hardware accelerated video, at least on YouTube, and thus save battery life. H.264 decoding should be available for virtually every single chipset out there unless it's really old. So if you enable that, at least on YouTube, you should also save some battery life if you have an older integrated GPU. Now that's one thing out of the way. Most distros should already have all of that set up correctly, but it never hurts to check because this could be a big reason why your laptop doesn't last as long as it's supposed to. Now, another very useful tool here will be TLP. It's an all-encompassing tool that will let you tweak a lot of settings to enable, disable, delay, and generally configure your system so it draws less power. It is, on the surface, a command line only tool, but fear not, there's a graphical user interface that is much more user-friendly here, called TLP UI. It is available on FlatHub in the AUR for Arch users, or you can install it with PyPI as it is a Python app. Obviously, it needs the base TLP program to work. You need to install that. Most distros repos should have it. If you use Ubuntu, Fedora, OpenSUSE, Gentoo, or Arch, you have that in your repos, or maybe even pre-installed. The package should be called TLP or TLP RDW. That second one, RDW, is to let you control Wi-Fi and Bluetooth to turn them off from time to time to save power when you're not using them. Now, once installed, TLP will run automatically in the background after the first reboot. If you open TLP UI after that, you should see that it is enabled, and you should get access to all the various settings. They don't have superhuman legible names, but if you go check on TLP's documentation, you have all the explanation of each one and what they do. The most important ones will probably be on the Disks tab, when you can set the time in seconds before your disk goes into idle to save some power. If you set it to 2 on battery, for example, 2 seconds after the disk has stopped doing anything, it will go idle and stop using as much battery as it did before. In the Graphics tab, you can set the minimum and maximum frequency of your Intel GPU if you have one, on battery and when plugged in. Same goes for your AMD GPU if you have that in the Radeon Power Profile settings. NVIDIA is not handled by this tool though. Probably because they do not have open source drivers available widely yet, so you just cannot configure that from an open source tool right now. You can also turn on Wi-Fi power saving mode, or you can change the CPU scaling governor from performance to power save when using the battery, for example. Another useful thing might be to disable CPU boost when on battery, to make sure the CPU never quite takes off when you're not plugged in. You also have the USB tab to put certain USB devices to sleep when they're not in use, and if you use a ThinkPad, there's even a dedicated tab for that. It is a very complete tool that will let you tweak a lot of the behaviors of your hardware. Think of it as the advanced options you could get on Windows in the old control panel settings. TLP and also TLP UI will come with a default set of settings which should work better than the default for most distros for most people. But if certain things are just not useful to you, you are welcome to try and disable some things, improve the delays. TLP UI will not let you input invalid settings. So at worst, you've disabled your Wi-Fi or your Bluetooth and you can just re-enable it from TLP UI. There's virtually no chance it will break your computer or harm it in any way. Now, if your computer has two GPUs, an integrated one and a dedicated one, You might also want to check which one you're using right now. When using your laptop unplugged, you might want to use just the integrated GPU, and when plugged in, the dedicated GPU instead. Now, the easiest way to do so is by staying in hybrid graphics mode. If you have an NVIDIA GPU and the proprietary drivers, you can just open the NVIDIA Settings app and head over to the Prime Profiles tab, and you can select NVIDIA On Demand. You close the program, you reboot, and you'll be using the integrated GPU for everything, unless an application requires the dedicated GPU, in which case it will be run using the NVIDIA GPU. Most good desktop environments will also let you force an application to use the dedicated GPU by right-clicking it in the menu or app grid and selecting Run using dedicated GPU or Run using discrete graphics. It also works on Wayland with NVIDIA, by the way. That's what I currently use on my own laptop, so you don't need to use X11 for that to work. For AMD GPUs though, I am not aware of solid graphical tools that let you switch between these, so you probably will have to use the BIOS to select that hybrid graphics mode. Personally though, I don't find the savings from turning the dedicated GPU really balance out against the usefulness of having that GPU at a fingertip, so I would much rather use hybrid graphics than completely disabling the dedicated GPU, but sometimes it might be what you need. Also, it is a good place to mention that if you use a computer from today's sponsor, Tuxedo, you can get their Tuxedo Control Center app, and it lets you handle that switching from a little applet, on top of letting you create really custom power profiles. Like, for example, I have one for battery, and I have one for max power when I'm editing or gaming. And of course, there are some other usual basic changes you can make. There's the usual screen brightness thing that can save you a ton of battery, but obviously if you're not inside, it might affect legibility. The display's refresh rate though is also a factor. When on battery, you probably don't want to run your display at 144 Hz or even 90 Hz. 60 is fine for most use cases when you're not plugged in. If your display supports variable refresh rate, it will also let you save some power. Some desktops already support it, like KDE. You can also turn off Wi-Fi and Bluetooth if you really don't need them, but you didn't need me to tell you that. And obviously, the more recent your hardware is, the better the chances that a more recent kernel and drivers will give you better hardware support and better performance and battery life. If you have a very recent CPU or GPU from Intel, AMD, NVIDIA or whoever else, do not stick to an old Debian LTS or an old Ubuntu LTS or anything based on that. Use something more recent. The latest Ubuntu releases generally have good hardware support, but also the latest Fedora or a rolling release distro, something Arch-based or OpenSUSE Tumbleweed. Do not use old LTS for recent hardware, because obviously you do not have all the latest features, all the latest support, and all the latest improvements. You might not even have solid enough drivers to run this hardware competently on older kernels. So don't stick to LTS if you have very modern hardware. You can also periodically run your system monitor to see what application or system uses the most CPU, and close these programs or uninstall them or disable the related service if you don't need them. And finally, there are also some very lightweight distros that will use the least amount of resources possible. Stay tuned for a future video on that exact topic though. I have some pretty cool recommendations that I want to share probably next month. So, if you have everything set correctly according to this guide, then you should definitely see some improvements to how long your laptop lasts when using Linux. I personally applied all of these tips to my laptop with a dedicated NVIDIA GPU and a recent 12th gen Intel CPU, and I routinely see 7 to 8 hours of battery life with Wi-Fi on, 50% brightness, browsing the web, writing scripts, watching videos. I just don't do video editing. When I do, I get like 3 or 4 hours max, which is still not that bad. And of course, there are other tools like Auto CPU Frec or PowerTop. But both of these can have some impacts on how usable your computer are. Auto CPU Frec conflicts with TLP, and TLP is way more feature complete, so I would much rather use that. And PowerTop, I tried, but it tended to disable my mouse and keyboard way too often on its default settings, meaning that sometimes I typed something or clicked on something and my computer would take a second to react or not even register these keystrokes or clicks. So I would much rather not put it in this video for those reasons. But of course, those are tools you can still check out. So hopefully you learned a thing or two, and maybe this will help you improve your battery life on Linux, just like it did for me. So thanks for watching, I hope you enjoyed the video. If you did, you know what to do. There's this like button, subscribe, the notification bell, the comment section, whatever else. And if you really enjoyed the channel, I left plenty of links in the description of the video. Becoming a Patreon member or a YouTube member will let you get access to a daily Linux and open source news show, on top of voting on my topics, a weekly patroncast, and a lot of other stuff. So check that out in the description. In the meantime, thanks for watching, and I guess you'll see me in the next one. Bye!